Well, hello. I just had a mint, so if everything is just unusually minty right now, that would be me. Speaking of mints, let's mince ourselves all over this thing. We're continuing to work with exponents, and we're kind of looking for a pattern that involved with a power raising to a power with exponents. So like for instance, if we start with 4 to the 5th power to the 2nd power, what this is saying, and this is saying I've got 2 4 to the 5th, so it's 4 to the 5th times 4 to the 5ths. Okay, so one of my rules that I have is the bases that if they have the same base and they're multiplying, I can add the exponents. Or in this case, I can see that I'm doubling them. There's 2 of them, so I'm doubling them, and that brings me 4 to the 10th. When I look at my next one, it's 3 to the 6th power to the 3rd power. That's a power to a power. So it's 3 to the 6's. So 3 to the 6 times 3 to the 6 times 3 to the 6, which if they have the same base, I can add their exponents, the product rule. And 3, and I've got my 3 6's, so actually it's 3 6's that are happening, which is 18. So again, we're kind of looking for a pattern, looking for a rule that you can use. So 5 to the 8th power to the 4th power means there's 4 of these 5 to the 8ths. So there's 8 there's 8 of them coming together. Or we can see, oh, there's 8 of them coming together, there's 4 of these 8s coming together. So I could do 4 times 8, which is like 32, 5 to the 32nd power. That's a lot going on here. All right, why don't you go ahead and press pause and you try 4 through 9 and see if we end up with the same answers. Again, you're looking for a pattern, something you can use when you're doing power to power. All right, some of the fractions were a little bit funky, but it kept it really interesting. I mean, we have 5 to the half power to the 4th power, so we have 4 halves. And when I do that, it ends up being 4 over 2, which simplifies to 5 to the 2nd power. Same thing happened up over here, where I'd end up with 4 to the 3 over 3 power, which is 4 to the 1st power. So keeping track of these things. So it looks like a rule that we can kind of see here when you raise a power to a power, that m to the n power to the z power means I can take and multiply my n and my z together, multiply my powers together. Wonder exponent powers go. Okay, now this is a little bit interesting here because now we're powering up a few different things in here. We have a coefficient that's powering up and a variable that's powering up. So we have two 3n's, so it's a 3n and a 3n. So I can double my, or not double, but I can square my coefficient and square my variable. So it ends up being 3 to the 2nd power, 3 squared, and n to the 2nd power. This ends up being total like 9 to n to the 2nd power. I'll do number 12 also, and then I'm going to have you finish up. So we have 3 to the x's, so 2 to the x times 2 to the x times 2 to the x. So I have 3 of these that are multiplying together, so I have 3 coefficients of 2, so it's 2 to the 3rd power, and I have the 3 x's, so it's 2, or x to the 3rd power. Why don't you try 13 through 15? I hope one thing that you're catching with here is that when you have a power going into a parentheses, you need to distribute the power to everything that's in it. So to raise power to power is kind of what we're practicing here. So 5 x to the 5th power to the 2nd power. This is playing out the same thing, and this is kind of what we're looking for. We're looking for that you can just multiply the exponents together when you're doing a power to power. And this can happen in a couple different places. So if I have 5 to the 4th to the 2nd, that's 5, 4 times 2, which gives me the 8. If I have a to the half power, and then it's to the 3rd power, that is saying a to the half times 3. So that can be a to the 3 halves power, which you and I know because we've been working on this is your power, so a to the 3rd, and this is your root. So it's actually saying square root. So this a to this 3 halves power is saying the square root of a to the 3rd. We look over here, m to the third to the fifth, saying m 3 times 5, so there's 15. M times itself 15 times, holy moly. And then I have x to the half, and I think that's a 2/3, it looks like. So x to the half times 2/3, I end up with x to the 2/6, which equals x to the 1/3. And we can see that as here's my how much I'm squaring up by, and here's my root. So this is saying the cube root of x. So 1 on the top, the numerator, is my power, which is right here. And then my index is right there, my root. Exciting stuff. All right, simplify the power. So let's try these out. So this represents as n4 times 7. So we've got n to the 28th. Simplified form of this, we have x, and we have 2/3 times 1/2. So I end up with x to 2/6. Oh, this looks like something we just did. So it's x to the 1/3 power, and just to keep showing a little bit, this is my exponent, so it's x to the first, and this is my root, so it is actually saying this. The cube root of x is really what that's saying. But this would be the answer I'm looking for. X to the 1/3 power. Oh, look it, you get to try some. Press pause, give it a try. All right, how do you do? Take a look, and p to the 8th power is actually saying the 8th root of p. But you can leave it like this for now, because that's what we're working on. What's next? What's next? How exciting. Oh, simplify an expression with powers. Oh my goodness, these things are everywhere. All right, it's simplified form. Okay, so my exponent right now is only attached to these parentheses, so I can take y to the third and kind of put it off to the side. I am going to multiply it eventually, but right now I have y 5/2 times, okay, this is times -2. Okay, so let's see how that plays out. So that's y over -10/2, which is equal to y over y to the -5th power. Okay, so I have this piece and I have this piece. So let me bring all that over here together. So I have y to the third and y to the -5th. Now, there's something that I know. Okay, the product rule tells me that if they have the same base, I can go ahead and add the exponents. In this case, I'm subtracting them. So this ends up being y equals -2, y to the -2nd power. So I'm getting tangled on myself, but I'm not going to leave that negative exponent. I'm going to simplify this down to even more, because a negative exponent doesn't mean it's negative. It just means it's small. Okay, why don't you go ahead and try some of these guys down here. I got 3 yummy ones for you. All right, just keeping track of those negatives and what they're doing in our equation. Take a look. Please see any misconceptions you have or any errors that you might have made. Really focus on them, reflect on them, so that you can learn from some of those things. That's the great thing about errors, is you can make them and fix them. You can use repeated multiplication to simplify an expression, like 4m² to the third. So with the 3, you get your 3 coefficients together, and then you've got your 3 variables to the half power together. And you can end up with 4 to the thirds and m to the 3/2. 4 to the third power is 64, and you end up with 4 to the 3/2. Property of raising a power to power. So a couple things we noticed, again, when we kind of put this together, is you need to distribute both of them. You need to distribute both of them, so it's been the 3 to the 4th power and x to the 4th power, and 3 to the 4th power can be simplified to 81. Same thing here with 4b, and I think that's 3/2, so it's 4 to the 3/2 power and b to the 3/2 power. 4 to the 3/2 power. Okay, let's look at that again. 4 to the 3/2 power. If you remember, this is the power, and right here is the root, so it's saying square root. So 4 times 4 times 4, the square root of that ends up being 8. Some of you might be like, what? Okay, it's right here. So 4 to the third power, 4 times 4 times 4 is 64, and the square root of 64 is 8. So that's what we're having. We keep breaking it down. Break it down. Simplify it. Break it down. Break it down. So let's see what we're looking for here. Which expression represents the area of the square? So we got this whole area, so it's 5x third, but this is squared. This whole thing is squared, so let's square this out. So this is saying 5 to the second power, x 3 times 2, so this is 25, and this is 6. So 25x to the 6. Zing! Chickazow. Ooh, look at, here's some fun ditties for you. Give it a try. I'm excited. Okay, and these guys right here, just a couple things to keep an eye on when you end up with like a negative exponent. Remember, it's not negative, but it's little, it's small, it's a fraction. So just transfer it over as a fraction, because in our final answer we don't want to have negative exponents, and we can keep cleaning it up. Just a little thing you want to keep an eye on when you're doing these things. All right, looks like we're done. Sweet bucket of lava. All right, I'm going to go and, what should I do? I'm going to take my shoes off and go and squish my feet in a big bowl of lime jello.